Okay, so next example, we have a new case. Okay, so what if we have an overhang beam? So sorry na lang sa scale. Okay, so for example purposes lang naman. Okay, so again, let's name joint A, joint B, joint C. Okay, and then this one is the overhang. Okay, overhang. Let's call it overhang. So, okay, so let's give this name. So, at joint A, no, member AB is connected. So that is AB. At joint B, we have, okay, we have BA connected, so joint B, and then we have B and C connected at joint B. Okay, and then we have C and B sa joint C, and then sa overhang, you just call it overhang. Okay, and this overhang is also connected at joint C, itong member na overhang. So I'll just give it a name na C small overhang. Sige, kompletuhin ko na. Okay, overhang. Ano na lang, COH for overhang. COH. Okay. And then, since walang binigay na I, so I will just assume it blank, or we give it a value of 1, or we just give it a value of 1 para sa madaling computation. Okay. And then the length of AB is 6 meters. The length of BA, member BA, is also 6 meters. So since they are basically the same. Okay. Okay. And then at joint or BC, the length is 9 meters. CB is 9 meters. And then sa overhang, we don't need to give it a length. Okay? Pagdating sa overhang, don't give it a length na lang. So it does not matter gaano kahaba. Kasi walang maproproduce na stiffness yung overhang. Okay? So, let me write it here. Overhang will produce no stiffness. Okay, so next is K. So I will just use the relative stiffness. So this is relative K. So relative K is 1 over or I over L. Since hindi binigay si I, we can use 1 over L. So kaya ko na nilagyan ng 1 value yung dito para sa Excel madali siyang ma-compute. So that is, since value nito is 1, I'll just divide that cell by L. Okay, and then I can copy paste this formula hanggang doon sa CB. Sa overhang is hindi, since wala nga siyang stiffness na maproproduce. And then sa distribution factor, okay, so distribution factor is K over summation K Sige, para pakita natin, lagay ko na lang dito yung summation K computations. Bisin ko muna yung mukha ko. So that is summation KA, that is equals to, ano ba yung mga joints or mga members na connected sa joint A? Oops, ba't ko dinalit lahat? So member AB is connected at joint A, and member AB has a K, no? KA B. Okay, and sino pa? Connected din sa joint A is a fixed support. Okay, so that is a fixed support, so that is plus K of fixed. And that is KAB is 0.167 plus, kapag fixed, we assume it to be infinity. So this reaches infinity. And DFAB can now be computed as KAB naglag over summation KA, so that is 0.167 yung KAB natin over infinity, and this converges or reaches a limit of 0. Kaya nga kapag fixed, madalas lalagyan na lang natin siya ng DF na 0. Okay. Next is KBA. So let me erase this one. That is KBA plus what? So ano ba yung mga connected na members sa joint B? Si BA, si BC, and yung roller. So that is KBA plus KBC plus roller. So that is KBA is 0.167. Ito yun. Plus KBC 0.111. Ito yun. Plus yung roller is 0. So we can do that easily. Hindi ko na ano to. KB ito. Summation KB. Summation KB is equals to sum or equals to 0.167 plus 0.111 plus 0, which is yun, plus 0, pero that is the same. So if we will compute for DFBA, that is KBA over summation KB, which is equals to 0.167 over 0.111. This is equals to sorry, not 0.111. It is 0.278, so that is 0.278, so that is 0.1 0.16767. Ayan, so sorry sa corny kong joke. 0.167 over 0.278. So that is 0.600719. So let's see if pares yung makuha nating answer if we just directly put it in Excel. So that is equals to KBA, no, yung sa DF. Sorry, naglalag. KBA, which is this cell. Okay, so let me erase muna. Equals KBA over sum of these two. Sum. So we just add KBA and KBC dun sa denominator. So that is 0.066.600, which is basically the same nito. Nag-round off lang siya automatic sa ano natin. So we can show it, no? Yung so ano siya, 0.600. Okay, next equals, so ganun din naman. So I will skip na yung manual over sum of these two. Yes. Ayan. So, 0.4. And dapat pag pinag-add natin yung dalawa, we should have an answer equals to 1. So, dapat yung total ng sa interior is 1 kapag pinag-add natin yung distribution factor ng dalawang members na connected at a given joint. Okay? Next dito, that is we can see, I'll just clean up this drawing. As we can see, that this part or yung part na to is a roller. Can we treat it as a end support? Do you think? The answer is yes, kasi yan yung pinakadulong support. Wala namang support dito kasi overhang. So kapag dulong support is roller or pin, di ba? Kahit hindi mo na i-compute, makuha mo dyan is 1.0. Okay. Okay. So, sa overhang is wala kang nilalagay na information. And then we solve for FEM. So, I have here yung mga formulas ng FEM. That is, give it negative lang, diba? Kasi to indicate na counterclockwise direction. Kasi sa computation, kailangan niya ng mga signs para malaman ng math computation natin if ano yung direction natin. Okay, so sa unang span, no load. So, ibig sabihin nun is no FEM kasi wala ka namang load na nakalagay. So, you need, so M FEM AB is 0 and FEM BA is 0 automatic since no load. Okay, and then dun sa BC, sa BC, isa lang naman yung nag-act na type of load. So we can compute using this formula. Okay, so this is the case na gagamitin natin. Okay, so that is negative 10 L. The L is the span of the member. That is 9 meters squared over 12. So that is equals to, compute natin, pwedeng gamitin calculator si Excel. Equals to negative 10 times 9 squared over 12. So that is negative 67.5. Okay, no more 6-7 jokes. Ayan. FEMCB. Katanda ko na, tumatawa pa ako sa mga sa mga 6-7 na joke. Anyway, so that is 10 times 9 squared over 12. That is also equal to 67.5. Ayan. So let's input. So FEMAB. FEMAB 0, 0, and then negative 67.5, and then 67.5. Okay, and then dito lang magkakaroon ng input sa FEM sa overhang. Since dun sa overhang part, no, since yun nga, yung ginagawa natin is we assume that the beam is dismembered and fixed muna sila. So pinag-iwa-hiwalay natin. So pag finix natin sila, siyempre kaya nga tayo nagko-compute ng FEM. So we imagine na initially they are fixed. So, yun yung process ng moment distribution. So, pagdating dito, nagmukha siyang cantilever. Hindi na overhang kapag in-imagine natin na fix. So, pag ganun, magkakaroon din siya ng FEM, itong 30 na nasa overhang. Okay? So, again, ginagawa natin, bigyan natin ng kulay. So, ito yung hindi nagbago. Tayo. Orange. Anyway. Ayaw po magbago ng kulay. Red na lang natin lahat. So, this is FEM AB. This one is FEM BA. This one is FEM BC. FEM CB. This one is FEM of overhang. Okay? So, sa overhang, meron siyang FEM. So, ang kaso lang, wala kang formula for FEM sa overhang. So, paano yon? Isa lang, no? Wala kang... Isa lang yung FEM mo, dito lang. Okay? So, kasi ina-assume lang natin na, ina-imagine lang natin na fix siya initially sa mga joints. Wala namang joint dito eh. So, wala ka nang lalagay na fix dyan. So, ayan. So, FEM overhang. We can compute it easily by treating it as a cantilever nga. So, kung cantilever siya, no 4 meters, pwede ba natin kunin yung moment dito? Pwede naman. That is FEM of overhang, summation moment at this point. Okay. Summation moment, since joints ito, summation moment at C equals 0 for this diagram lang. Okay, that is, this is FEM overhang. FEM overhang, which is acting counter clockwise, so that is negative. Tapos this one will produce a clockwise moment about C, so that is 30 kilonewton times 4 meters. So transpose lang natin equals 0. FEM overhang is negative 30 times positive 30 times 4, so that is 120 kilonewton meter. Okay. Okay, so 120, but it is value lang yon. Kailangan natin lagyan ng direction. So, since nakuha natin or inassume natin counterclockwise and then we get a positive answer, ibig sabihin tama yung inassume natin na counterclockwise to. So, pero dito sa computation, since hindi mo naman masasabi sa Excel na clockwise mo isosolve or counterclockwise. So, we just give it a value of negative 120 to indicate that it is clockwise. So, sana nakakasunod ay na counterclockwise. Center ko lang. Okay, and then the first distribution, ang tanong, pwede ba nating apply yung modified stiffness? Pwede ba natin apply yung modified stiffness? Hindi tayo ma-erase. Can we modify or can we use modified stiffness? The answer is yes. Yun, saang part? Dito ba? Or dito? Okay. So again, sa mga end supports lang natin siya tinitingnan. So, sino yung qualification? So, balikan natin itong dito ko nilagay. That dapat yung dulong support is a pin or a roller. Pala yun. So, yung dulong support is a pin. Tama ba? Or a roller. Ito, no. Hindi. Fix yan. Ito, yes. So, yung Mag-apply tayo ng modified stiffness at this one. Okay? So, sino yung modify natin? Yung let me erase yung interior support na member na yon na merong end support na pin or A-roller. So, yung member na to, yung merong end support na pin or A-roller, which is at this one. Yung dulong support. And yung minomodify natin is the interior joint, which is, ito yung interior joint. In this case, nung sa member. Okay? So, we modify it. We give it a 3/4 of K. Okay? So, 3/4. Sino yan? This is BC. So, KBC. Hindi KBA. Ha? Kasi in the context of BC tayo. This one. So, modify lang natin si KBC. Ito yun. So, maglagay tayo ng factor na 3/4 sa harapan. 3/4 times yung original K natin. Yan yung magiging modified stiffness natin. Okay, as you can see, pag pinag-add pa rin natin itong dalawa, it will be equal to 1 pa rin. Okay, so first distribution. Okay. So, ano ba yung mga moments na mag-act sa first, sa AB? Or sa joint A, I mean. Ito lang. Yan lang yung mag-act na moment at joint A. So, we apply a negative sum of that times the distribution factor. And then, sa Excel, I just lock that cell para hindi mag-move. Okay? Pagdating dito, this is equals to negative sum of these two times, kasi yan yung mag-act na moments at joint B times this distribution factor. Okay, so parang mabilis, I can drag it. Ang kaso, nagbago yung selection ng cell. Ang gusto ko pa rin is sum the moments at joint B, which is these two. Okay, hindi ito. Ito dapat. Tapos, ito doon. Kasi minomultiply natin siya sa distribution factor niya. In this case, member BC yung kino-consider natin. So, we must multiply it to the distribution factor BC. Okay, next is equals negative. So, based on sa modified stiffness, we will only balance once. Okay? So, balance only once. That is negative. Let me erase. Equals negative. Okay, ulit. Equals negative sum. So, what are the moments acting at joint C? What are the moments acting at joint C? So, bago ko pakita natin ano yung mga moments na nag-act sa joint C. C, FEM, CB, and alam natin na merong galing sa overhang. Okay? So, we must add those two. Equals the negative sum of the moments acting at that joint, which is FEMCB, and the fixed end moment produced by the overhang part, times the distribution factor. Okay, so Dito, wala na tayong lalagay dyan. Okay, so hahayaan na lang natin yan. Okay, and then carry over. So carry over moment, sabi. Let me erase. Okay, no moments will be carried over the end support na pin or roller kapag gagamitin si modified stiffness. Ayan, so since ginagamit natin si modified stiffness dito, so ito magka-carry over doon, so we divide this by 2. Yan magka-carry over. Okay? Ito magka-carry over ba? Hindi na, kasi yun yung end support na pin or roller. So sabi doon sa definition is wala kang i-carry over doon sa end support na pin or roller when you're using the modified stiffness. Dito ba meron ma-carry over sa part na to? The answer is yes. So ito kay-carry over mo pa rin dito. Okay, so pupunta ito doon. So, paano natin ginagawa? So, we just divided by 2. So, equals this one. Let's divide that by 2. This one, we divide this by 2. And at this part, the interior part, may carry over pa tayo, which is galing dun sa end support. Pagdating dito is wala na. Okay? So, I will just copy this. Second distribution, carry over moment. And then for the third distribution, ayan. So as you can see, sa third distribution is wala ka nang makuhang value. So ibig sabihin, you have done it correctly, no? So kailan ba tayo mag-stop? Actually, hindi naman rule na hanggang third distribution lang. Hindi rin rule na hanggang fifth distribution lang. Hanggat hindi mo napapaliit yung mga cycles of distribution mo or yung mga numbers na lumilitaw sa cycles of distribution mo, you can still go forward, no? Pwede kang mabot ng 10 distribution, 11 distribution kung masipag ka. Pero kapag sobrang late na, you don't need to do those hard work. Actually, you can stop na at second, dito, in this case, third distribution, since pagdating sa third distribution is wala ka na nakuhang value. Okay, so ibig sabihin that is enough. You don't need to do another carryover and fourth distribution. And then the last one is you take the summation moment from the FEM hanggang dun sa last distribution, in this case the third distribution, and then you ayan. As you can see, dapat balance yung mga sa joints. So we can also sum this one, since wala naman, mananatili lang siya negative 120 niyan. Okay, as you can see, dapat balance yung mga sa joints. Okay, sa joint A, ito lang, since fixed siya, hindi talaga yan magiging 0. Sa joint B, it is an interior joint. Dapat sa interior joint, pag pinag-add mo yung nakuha mong final moment from, for example, this one, BA and BC, dapat mag-0. So 27.5 minus 27.5, that is 0. And then sa joint C, hindi lang naman siya natapos doon, meron siyang overhang. Kaya nga, nung in-add natin, 120 minus 120, 0 pa rin. Okay? So that is how the solution will work. And then, siyempre, the next part of the analysis is do a section analysis. Ito yung mabura. So, do the section analysis, the next step. Hindi ko na siya papakita in detail. Find the values of shear acting at the joints. And then find the reaction. So papakita ko na lang yung diagram pero hindi ko na siya i-solve. So ito yung magiging section analysis mo dapat. Meron kang AB, so for member AB, meron kang VBA. Okay. So, mga moments mo is both positive. So, 13.75 positive. So, ibig sabihin that is clockwise. So, clockwise moment pala siya. 13.750. And then positive din 27.5, so clockwise din. And then solve for VAB and VBA. Next, another section is BC. That is meron kang nag-act na load na 10 kN per meter. And then 10 kN per meter. Tapos, meron kang shear sa joint B, which is, in this case, since BC ito, member BC, VBC, and then VCB. And then, check the final moments na nakuha mo. VBC is negative 27.5. So, negative 27.5, ibig sabihin it is counterclockwise. So, we have negative 27.5 counterclockwise at this section, and then dun sa kabila sa yung mouse 120 positive. that is clockwise. Okay, and then solve for VBC and VCB in this section. And then lastly, okay, you have the overhang part. Okay, VC overhang, and then meron kang 30 kilonewton nag-act dito, and then overhang moment mo is negative 120, or yun lang, negative 120. Kaya ma-erase. Tayo ma-erase. Wait lang, nag-lag siya. Anyway, ayaw ma-erase eh. Ito, negative 120. So that indicates a counterclockwise moment. Counterclockwise na 120. Ayan. And then you do the analysis of each. Okay? So again, the reactions. You just add all the shear forces acting at the joint. So reaction A is ano yung mga shear force na nag-act sa joint A? Si VAB lang. Reaction B, ano yung reaction na nag-act sa joint B? Okay, si VBA plus VBC. Reaction C, ano yung mga shear forces na nag-act sa joint C? VCB and yung overhang shear. Okay, so yun lang yung process. Yan, so I think I will leave this to you as an assignment. Okay, yung computations ng mga yan. And then, siyempre, shear and moment diagram. You draw the shear and moment diagram. I think that will be also given as an assignment na lang. Ayan, so thank you.